There you go, you are not.
All right, well, good morning, everybody. My name is Michelle Crepeau, and I'm the museum conservator for the North Carolina Maritime Museum System. That means I'm the artifact doctor. My job is basically to make sure that our artifacts inside the museum stay healthy and happy for as long as possible. And one of the things I do is I am in charge of what is known as the Integrated Pest Management Program at the museum, the IPM program. And what this does is a way to monitor the different types of insects that come into our museum to make sure there's nothing there that could pose a threat to the collections themselves. So today's lecture is going to be what I call Museums Most Wanted. It's going to be talking about what IPM is, some of the, I guess, most common offenders that we're on the lookout for in terms of what is most wanted and what is least wanted. And then also some of the ways that we act to both monitor the situation as well as to know when to act in terms of rolling out mitigation and what those look like in the museum setting. So just a disclaimer, here there be bugs. This is a presentation about pests in a museum. So the photos of insects interacted. So if you're a little bit squeamish, just be on guard for that and just prepare yourself. I promise there's nothing too gruesome. I tried to take the cutest, derpiest photos I could of these insects. So hopefully you get a little laugh out of them and nothing else. So to start is, what is a pest? So a pest, much like a weed, is simply an organic organism that is existing in a place that we don't want it to as humans, because it is in some way deleterious to our activities and our way of life. So this could be food pests that either threaten or damage the food that we grow, such as agricultural crops, which you might be more familiar with in terms of IPM, as well as insects that can be deleterious to the environment that we're trying to maintain. We're trying to maintain a particular type of ecosystem or environment. They could also include threats, insect threats, or other pest threats to our homes and infrastructure, things like termites that are trying to eat our roofs and floorboards out from under us. And also, a pest can also be things that cause harm directly to people or our livestock and animals, things that are just kind of annoying, like mosquitoes, to things that can also be vectors for disease, such as also mosquitoes. So when we talk about pests in a museum context, what we're talking about is pests that we don't really want in the museum for some reason. There's always going to be some level of insects that get into our museum, especially here in the South. It's just kind of how it is. They have evolved to be able to get into the nooks and crannies and get it in and out of various spaces to get their resources. So basically, to know what a pest is in terms of museum, we have to kind of give on the idea that we can never fully insulate our environment from pests themselves. So what we really kind of want to do is think of more like a pest in terms of what damage it can do to our museum environment in terms of, okay, so the bugs are coming in. What are the reasons that they're coming into the museum? So it could be so first of all, how are they getting in there? They could be coming in of their own volition. They can also be coming in the soil and potted plants. They can be coming in the artifacts themselves at times, or in furniture or other sort of goods and supplies that we bring into the museum. They can also be coming in due to other type of animal activity, especially things like squirrels and rodents, other type of birds, and other types of animals that can maybe also nest or get into the museum. We're also coming in of their own volition for various reasons, including hunger and thirst. They're being drawn to resources so they can feed themselves, so they can stay hydrated. They're coming in as a way to escape danger or some types of environmental pressure that is pushing them inside. So whether that's predation or environmental factors that are deleterious to their existence, that could be pushing them inside their building. They might be coming in looking for love. They might be coming in looking to reproduce and find a mate. They might also be coming in just because the inside environment of your home, of your building, of your museum is for whatever reason just more conducive to their life circumstances. It's a better environment for them. There's more food, more water. It's just kind of a cozier, more sort of optimal situation for them or for their brood. So if they're coming in to nest or lay eggs as well. And these needs can differ depending on their life cycle. Adults versus larvae versus juveniles all have slightly different needs and different eating habits that could change why they're coming into your building, as well as seasonal. We'll have a lot of seasonal as well as weather conditions that will change what we're seeing inside the buildings as well. So, but in terms of museums, the impetus for coming into the building that we're really on lookout is hungry bugs. We are looking for bugs that want to eat our collections. They can be plant eaters, so they eat mostly plant products. They could be meat eaters or other type of animal product consumers. They could be both. Many insects, depending on the life stage, will eat different things and have different feeding habits based on their life cycle. And generally speaking, an infestation is when we have all parts of the life cycle present in a building at a certain sort of danger threshold. So we'll get into that a little bit more often, but an infestation is where you have basically eggs, you have larvae, you have juveniles, you have adults. You basically have a thriving population living inside your building that will not sort of naturally stand down. Pest crimes. What are our insect felons trying to eat? Well, there's different types of materials they may be drawn to, one of which is cellulose, which is the primary structural of most sort of plant-based materials. So this is essentially very long cellulose molecular chains composed of sucrose, which is a sugar, which is a tasty little tidbit for many types of insects. On a macro level, the sugar builds up into kind of higher levels of complexity into a macro level, so you get these like large cellulosic fibers. And these are the basic structural components of things like wood, as well as any type of natural plant-based textile material. So anything like, flax-based, cotton-based, hemp-based, any type of plant-based material that we then kind of turn into thread and then make into textiles or textile-based materials. Also paper, canvas, things that are made from tree pulp or plant pulp as well, are also tend to be what cellulose composes in a museum. So what types of collections contain these types of materials? Well, there's libraries, archives, which are obviously paper-based. There's also textile and fiber arts. So you have a large costume collection, textile collection, or textile arts and fibers. That could be endangered. Wooden objects, wood itself is of course made of cellulose, as well as upholstered furniture also tends to be a very big issue just because they tend to be more complex artifacts. They have more components. So they have wooden structure, but they also have plant-based upholstery, batting, things of that nature as well. They can all potentially be tasty to a hungry cellulose eater. And also things like paintings, works of art, two-dimensional things like maps and drawings. These are made of cellulose, either because the backlinks are made of wood or what they're painted on is canvas or paper. So these are also tasty goodies. There's also botanical collections when we think about our natural science collections or sometimes even art collections where we have large collections that are composed basically of plant materials. Those can be very attractive to a hungry insect. On the other side, we also have protein-based eaters. So these are essentially insects that like to eat proteins, which are the building blocks of most animal products, as well as also some plant proteins as well. They're another structural component. They are composed of amino acids, which form long peptide chains, which then in kind of greater and greater forms of complexity can be plated, folded, and create large configurations that end up also creating large structural fibers that are kind of basis for making up protein-based organisms like you and me. There are various types of major structural types of proteins that they're going after. Collagen is a major one. This is the major structural component in things like skin and leather. There's also collagen in your connective tissue. So when we're thinking about like rawhide, sinew, anything that is made of sort of a connective tissue or sort of muscle-based is also collagen-based. And there's also things in organic species. There's composite materials, our bones, teeth, antlers. These are all things that have mineral components, but they also have proteins in them. They are a hybrid structure. That's called a hydroxyapatite layer. So these are also things that might attract insects as well. And then keratin is another well-known structural protein that's in a lot of organic materials. It is the basis for hair and fur and wool. Also the basis for things like feathers, and also things like your nails, which in an animal we might term as a claw, or hoof, or a horn as well. These are all materials that, even though they seem almost inorganic, are actually organic materials that are made primarily of proteins. So, and there's also some things that you may not think of as readily. Casein is a major protein in milk, for instance. Casein has traditionally been used as an adhesive, as well as a grounding surface for a lot of painting, especially things that are painted on non-traditional surfaces, so meaning not on canvas or paper. Things like a lot of wall paintings, paintings on wooden panels, for instance, they might have a casein-based ground that allows the pigment to adhere to the substrate. Also, I'm sure some of you have heard of egg tempera as a medium for painting. Basically, that means that the binding material that is holding your pigments together is made from egg. So there's also egg proteins in a lot of pigments and other materials, also used as adhesive at present. And then silk. Silk is a fiber that we think of using our clothing. We think it's a textile, but it's actually a protein-based textile. So it is a byproduct of silkworms and other insects that we then use and refine and turn into a textile that we can use. Also, kind of going back to the bugs, a lot of bugs eat other bugs because bugs themselves are made of protein. So a lot of pests, some of the kind of epicenter for a lot of pest infestation, especially in natural science collections, for instance, are in your entomology collections, are in your bug collection. A lot of tasty bits on other bugs that other bugs want to eat. Also, we don't think about a lot, but plants do have proteins. There's a lot of high protein things like legumes and beans and seed casings and fungi and soy products, for instance, that have high, they're also very high in plant-based proteins as well. So even though we think of these as separate from animal protein, they still do have proteins in them that are very, very tasty to our bug friends. And then also bacteria, fungi, mold, these have what we call mycoproteins. These are also sometimes attracted to certain species of insect who will gobble them up. So what types of collections are in danger? So obviously things that are made of leather that have basically skin. So leather goods, leather products, things that are bound in leather. This also includes, once again, our most problematic child, upholstered furniture. Often contains protein components as well, such as leather upholstery. Also anything that is bound together or uses rawhide, sinew as a binder or as a part of its substance could be potentially targeted as well. Anything made of silk or wool, whether these are objects or textiles. Polychrome objects, so kind of going back to the idea of painted surfaces, surfaces that have paints that are, that use egg as a binder, that have casein as a ground or an adhesive, anything of that nature could potentially also be, weirdly enough, attractive to insects. And then also, of course, textiles and accessories, especially if you have historic costume garments, which maybe meant have, have actual feathers in them, not artificial ones. This gown, for instance, which is built in silk gown, and also is decorated with beetle carapaces of all things. So this is sort of a double whammy as something that might potentially be a target for insects. Also, of course, there are entomological collections, as I mentioned previously, as well as our specimen collections. Obviously, taxidermy collections tend to have a lot of issues with potentially protein-eating insects as well. So spare Mr. Mouse, please keep on the lookout for things that want to eat him so he can enjoy his living there. And then also botanical collections, seed collections, for example, or mycology collections, things that deal with fungi or algae and moss, lichen of that nature, since they're high in plant proteins. They can also be susceptible to being eaten. There's also materials that we don't necessarily think about, kind of going back to the casein and the egg tempera, that are components of artifacts that are protein-based that we don't necessarily think about. So horn and bone, for example. You've probably heard of animal-based glue. So we have like bone glue or fish glue or things that are made from animal products. These can also be incorporated into materials that we may not expect to have to worry about protein eating insects like book bindings and upholstery in. Also, upholstered furniture might also have filler that is things like horse hair or other types of animal hair or feather upholstery as well. So these are, again, things that we want to keep, or we know that insects like to eat. And also, beyond whether or not insects are actually actively eating your collection, they can also tell you about issues in your building as well that you might want to address. They can tell you about how porous your building is, how easy it is to get in and out of it. They might tell you something about water issues that we'll get into in a couple minutes, as well as structural issues of your building. So for instance, obviously insects themselves can cause damage to the structure of your building. If you have things like termites or wood-boring insects that like to eat the structure of your building, which can be particularly problematic if you are running historic property, in which case the building that you are in is part of the collection. Obviously, so the presence of certain types of species can also give you information about structural issues with the building that your collections are being kept in, or that is part of the building itself. Also, they can also tell you information about moisture issues or mold issues. As I mentioned, a lot of those insects are mold and fungus eaters. So if you see a lot of them, it might also tell you that there's water issues, there's damp issues, there could be mold issues, there could be mold concerns as well as potential health and safety concerns for you and your visitors. There's also, they tell you information about your housekeeping retinue, whether or not you need to improve it, whether or not there's a lot of dirt that's being tracked in that can either contain insects or contain nutrients insects might want to eat, or moisture, whether or not there's a lot of food waste if you have food is getting out of specified food preparation areas or food eating areas in your building, and also just sort of the general tidiness of having humans walking through your space, shedding skin cells and sweating and kind of providing little tidbits and snacks for our insect friends along the way. And just in general, like the most important thing they tell you is basically how easy it is to get into your building, how porous it is, how easy it is to enter and exit through either unsealed spaces or just structural defects, things like that. So how we deal with this in a museum context is very much like how farmers deal with it. It's, as I mentioned previously, it's called integrated pest management. And what it does is basically the philosophy that if you can identify and understand the types of pests that are around, and you understand their habits, how they interact with their environment, and you couple that with knowledge of how you can prevent their access to what you were trying to protect in terms of sustainable kind of mediation treatments or preventative treatments, then you can create a scenario where you can essentially keep them out of what you want to protect in a way that is both low impact to the environment and to people and to your collections and buildings as well. But it's essentially a methodology for how we deal with insect pests. And these are sort of the four main components. You set action thresholds, which is basically, it is the criteria that you create for yourself so you know when you need to take action. So what has to happen, A, B, C, D, 1, 2, 3, for you to know that there is an actual problem. And there can be various levels to this, that call for different types of action. In order to know what type of action is needed, like what your criteria is based on, you need to know what is around. You need to be able to monitor and identify species. Prevention, obviously, you want to know what we can then do to prevent potential damage to our collection or to ourselves. How do we keep damage from happening in the first place? And then control mitigation. When damage does happen, how do we mitigate it? How do we address it? So set action thresholds. So first of all, what we do at the museum is that we monitor what types of pets come into the museum. We set traps at key points around the building, which we'll get into more detail later, that allow us to kind of get a little sampling of what is coming in and out of our building. And then I go through and my interns go through kind of on a quarterly basis, those traps, and try to identify those insects to the best that we can. So as we talked about, not all insects are created equal in terms of the threat they pose to your collection. Although there are some insects that are very, very concerning if they're in your building. There are many that are just sort of there by happenstance. As I said, there are many reasons why bugs come into your building. Some of them are coming in for water protection, to find love, they're hunting other insects primarily, or they're just kind of wandering in incidentally. So helping to identify them will kind of let you know, okay, this is the insect we have, these are its habits, this is what it eats, these are the reasons why it's probably here. Locations, identifying where those insects are present in your museum. Obviously, not all areas are of high alert, necessitating direct action. You have a lot of areas, that might be your loading dock or your entrances, where if you're finding insects, you can kind of shaft it up. Well, this is a very obvious egress. There's material and people coming in and out here all the time. It's kind of reasonable that we would see insects here. And most importantly, they are not really close to anything in our galleries or anything of particular interest. However, if you're finding insects in the collections that you are concerned about, obviously that sort of ups the danger level and kind of pushes you closer and closer to that action threshold. And also population and frequency. So that means how many of these are we seeing? How often are we seeing them? And sort of, are we seeing them in any sort of like all the time or just in certain types of years? So if you're finding one or two individuals, even in a collection space, but you're not finding them, you found them once and never again, you can kind of determine that, oh, maybe this is a historic infestation, or, some bugs did get in here, but there weren't enough of them to actually sustain a population and create an infestation. So that's why we also look at the count. So we keep track of the numbers that we're finding and are able to sort of extrapolate that into larger population information. So for an example, a classic cellulose eater that is a danger to collections, especially archives and libraries, are book lice, book lice and their cousins bark lice. They eat cellulose primarily. They're also very tiny and hard to see. However, even though they can be very, very dangerous if they're actually in your collection, they also just sort of are there at times. They tend to are attracted to wooden buildings. They are attracted to damp, to darkness. So they could also be, you also might just sort of find them in threshold areas around your building, around baseboards. So then the presence of them in your museum is not necessarily cause for action in terms of, okay, this is actually an infestation, we need to deal with it. It might just mean that we need to monitor for this because we are noticing the species. However, it is not necessarily in a location that is close to collection, and we're only seeing one or two, and only after very certain weather events like a rainstorm and things like that. So we have an idea of what's pushing them in here, and they don't seem to be spreading any further than this one area. However, if you were to find them in a library, again, that would obviously sort of increase your action, your sort of the steps to reach that action threshold, because obviously you have species that could be detrimental in a collection that could actually cause some damage in. But again, you might find a book that has either evidence of book lice activity or even some maybe dead or dying book lice in it. However, if you do, unless it is an active population, it may be a historical event. It may not also, it may not determine that it is not an active infestation that needs to act either, which is why also high number and frequency are also important. So that's keeping track, like, are you seeing multiple instances of book lice in your library? Are they in multiple books? Are you seeing evidence of all life stages of this insect, including, eggs, larvae, and adult species? So these are all elements that go into telling us when we need to act. And in terms of what are the species that we're most on the lookout, in the museum world, we have a phrase called the dirty dozen, which are the 12 or so insects that tend to be considered the most dangerous for museum collections in general. This will change kind of slightly based on country and region, but for the most part, there's some frequent flyers, we'll just say some known entities that kind of show up. We do monitor for all life stages of these insects, although a lot of them, how destructive they are can be very dependent on life stages. A lot of these, the adults, if you find adults, that might just be indicative, okay, something could be laying eggs, but the adults themselves may not be causing a lot of trouble, but their larvae and juveniles sure might. So that is why we also monitor for all life stages. All right, so to go down the list of the dirty dozen, number one is our friend Leptisma saccharina, also known as the silverfish, sometimes also called fire brats. They have other names as well. We actually kind of just think of them as being kind of gross and nasty, living in your drains, but they actually do like eating paper and other cellulose starch-based materials. So they can be detrimental to your paper collections. They also are just kind of what they are often described as having water mania. They love water, so they can also be indicative of water issues in your building or your site as well. Physical descriptions, they're pretty well known. They're this kind of distinctive silvery color. They have long antennae, long bottoms, bodies, and then these very distinctive three-pronged spikes or sort of tail structures at their end, the prongs of their tails. So that is most wanted number one, silverfish. And of course, they love warm, damp spaces, so always in leaky faucets, so they can be a very good indication that there's something wrong with your plumbing. Number two is our friend the book lice, Lysocellus, various species thereof. Also, they actually are protein eaters, even though they are most detrimental to book and paper collections. They actually do eat proteins. They're sort of after the glues in your books, as well as fungi and mold, and they actually do eat other insects. They are weird looking little guys. They're very, very tiny, so you usually need some sort of magnification to really be able to identify them. They kind of look like little clear ants that are sort of splotch looking. They're very flat. And they have distinctive little waists or little thorax constrictions. And right here we have the clepeus, which is their nose. They have these very blunt nose ends. So they're actually kind of cute looking. There's the thorax constriction and the clepeus, just kind of beautiful. And they also like warm, damp interiors. This is a common refrain for a lot of insects as well. Next, you have Ethiopian Ptacum, aka the furniture beetle, and this is the single most dastardly of the beetles that can attack your furniture collection. What they do is they bore into your furniture to lay their eggs and larvae. The larvae then develop inside these boreholes and essentially eat the contents until they go through pupation and emerge as adults. What happens, however, is that they're also very tell that something is there. They leave very distinctive boreholes, and they are very messy. They are very, very messy insects, so that does benefit us in turning and basically being able to identify them. They tend to leave a lot of larval casings and produce a lot of frass or excrement. Basically, they make a lot of bug poop. that sort of overflows the channels where the larvae live and often end up in piles on the floor along with sawdust and other things. They are pretty easy to look out for in that regard. Adults are kind of brownish, red in color. They have these three elongated segments of the antennae. And the antennae, and then sort of probably the most, I guess, identifying feature is it's their thorax region over here. They have kind of a ridge that pokes out. So that's one way you can identify them. Their frass or their excrement, their poop is very, very fine. It's almost sand-like, so it also is pretty distinctive. And they really like both seasoned hardwoods and softwoods, so they don't really tend to have a preference. So basically anything that is a furniture collection item in particular, hence the name furniture beetle, is a potential victim. So they think they might protect again. Next, we have Stagnomium panacetum, also known as the drugstore beetle. These guys are interesting. They're a little bit omnivorous. They like to hang out in foodstuffs as well as leather, hair, animal protein products, upholstery. They love upholstery. And they are kind of known for being destructive as adults, but only because when they emerge from wherever they have been laid and have developed as larvae into adults, they don't really care what's between them and the outside world. They will just kind of bust through it like the Kool-Aid man. So they tend to be very destructive on their way out and their emergence. And that tends to be the majority of what, so larval, these kind of little grub-like things tend to be the eaters. They're what's eating your collection, but the adults are what causing a lot of the visible signs of the collection being eaten, because they're just sort of busting out and causing mayhem on their way out. Otherwise, they don't actually eat a lot as adults, so they have a very different food source as adults. So it's really the grubs that are the problems. So grub-like body. These do look very similar to another beetle I'm going to mention in a second. So some of the identifying features on them are these three clubbed antennae, as well as the grooves on the elytra. The elytra are the wing casings on beetles. You can see there's a very distinctive groove problem pattern on it. And they like to hang out in storerooms. They also like to hang out in commercial packaging. So they are definitely a species that you can sort of inadvertently bring into your museum in food packaging or other types of supply packaging. So they're definitely something that you want to take kind of the end in mind for. So this is the insect known as the cigarette or the tobacco beetle. Very predictably, it eats tobacco and other tobacco products, as well as book bindings, botanical specimens, other types of foodstuffs. Can be very damaging to manuscripts and upholstered furniture, much like its cousin. Again, kind of a very grub-looking juvenile, and it's really mostly distinctive from the drugstore beetle in terms of how it looks. As you can see, it has these serrated antennae, and its elytra is smooth, so it lacks those grooves. And also, they like to hang around in food storage, food prep areas as well. Next, we are getting into the clothes moth family. So this is Tinolia viscelia, for instance. These guys like to eat mostly protein-based things, so they tend to be most famously associated with clothing, especially silk and wool garments, as well as nice silk rugs as well. So they're definitely things to keep an eye out for. While the adults have a different food source that we want to keep an eye out for, and luckily they're pretty distinctive. They are called the webbing clothes moths because they essentially spin themselves little webs out of sort of stray fibers that they're interacting with, and create this very sort of messy, cobwebby effect on top of various textiles. And also, they're not very good at cleaning up after themselves, so often their frass is sort of matted and caught up in these silk webbing, essentially. So they're pretty easy to identify in that case. The adults are very interesting. They are what is kind of called 18-karat gold. They're very sort of buff, kind of old, sort of one color, gold color. And the most distinctive feature on both the adults and the juveniles is that they're red heads. So they have these very distinctive red tufty heads on the adults. And then the larvae have these distinctive reddish brown sort of head capsules as well. So those are pretty distinctive. And they also enjoy warm, humid, dark interiors as well. So that musty closet that might be a little damp tends to be prime feeding ground for these guys. Their cousin, Timmy Paleonella, also known as the case-making clothes moth, is another. So they also eat pretty much the same thing as their cousins in terms of eating wool, silk, feathers, a lot of animal proteins. They also are distinctively known for discarding their larval casings. They actually weave these kind of big fibrous plaques out of whatever they're eating that they essentially live in as little kind of sleeping bag almost. So they will kind of live in this case until they emerge as they pupate and emerge as adults. They're also cleaner than their relatives because most of their fecal matter stays inside their nice little cases that they make for themselves. And it tends to be a lot kind of separated and more sandy and look a little bit more like regular insect frass when it's not in these cases. So that's a good way to keep an eye out for them. Otherwise, adults tend to be light brown coloring, and they have these very distinctive 3 eye spots or 3 dot pattern on sort of their uppermost wings. They have 4 wings in total. And their larvae have these black head capsules as well, and tend to be very distinctive because they're literally carrying around a giant sack with them wherever they go. Capsule, also same environment preferences as their cousins. Now we're starting getting into the warehouse beetle, or sometimes called the cabinet beetle. Also a frequent offender against foodstuffs, protein, mostly animal and plant. Very, very big eater and your specimen collections. So definitely want to keep an eye out for this guy. They're the most distinctive, I think, they have this very distinctive sort of gold, tan, brown, almost kind of stripe pattern on them, so they do stand out. The grubs are a little bit more kind of yellow, white, reddish brown. They do have bristles, so basically large hairs that stick out around them, especially towards the end, even though it's not the best picture of them. And they like to live in cracks and crevices, especially in your food storage areas. So they're definitely something to look out for. Now we're getting into what is kind of known as the dermestids. So these tend to be our meat eaters. They tend to be our animal protein gluttons over here. So this is the black carpet beetle. They like to eat keratin, so feathers, horn, things of that nature, as well as seed grains and plant proteins as well. So they are omnivorous in that sense, but they are kind of going for the protein components of what they're after. They also have recently been identified as actually eating synthetic fiber, which is kind of interesting as well. I don't know if they could potentially have a use in cleaning up microplastics, but it's an interesting little adaptation we seem to be seeing amongst them. They are distinctive for having these very, very big globular bodies that are black or dark brown in color, and these very almost bunny-like antennae, spear-shaped antennae right here. The larvae tend to be black, striped, and this one, unfortunately, doesn't have one, so I don't think it's old enough. They also have very long, bristled tails on them, so they're very distinctive. But these can definitely be very bad for your protein-based collections, essentially. They, interesting enough, really like low humidity, which is kind of unique amongst the dirty dozen. Most of them really like warm, high humidity areas that are kind of damp. These guys really like dry spaces. So there's a season for there's an insect for every condition. This is Anthranius ravasci, also known as the varied carpet beetle. So called because of the variegated pattern, both on the adult and the juvenile. These are also well-known eaters of carpets and upholstery and other types of protein-based materials that are especially made of things like wool or silk, also keratin. Also really good eaters of other bugs as well. So they are, at least as larvae. Their larvae are one of the more destructively known species amongst this family of beetles. The adults actually eat pollen and things, so they have a very different diet. So if these guys kind of wandered as adults, they're not as concerning as the babies as larvae, which are what's really eating the carpet. As I mentioned, these adults have these, you can kind of see the texture is very distinctive. It's because they have these very long scales, and they have this very distinctive tricolored pattern, this kind of orangey brown, yellow, and white, and sort of darker brown, black color. The babies, as I said, they're kind of alternating cream and brown coloration, and they're very hairy. They actually are called woolly bears in a lot of places. Because they look very fuzzy. And they really like air ducts, closets, very kind of close, tight spaces. Also, obviously, areas where they can get it easily from the outside. Also tend to be found in rugs, under furniture, in upholstery, things of that nature. Next, we have the other types of dermestids, which you might be more familiar with, is the carrion beetles, also known as the skin bat beetles. We have the larder beetle as well as the hide beetle. And these are the beetles that are often used to help excarnate specimens in scientific settings, like the Museum of History or the Museum of Natural Science in Raleigh, for instance, employs carrion beetles of one of these species. They eat protein, animal-based protein, both as adults and as larvae, so they're kind of good little eaters throughout their life cycles for the most part. So yes, so they are protein eaters. They feast upon skin and hides and leathers, other types of protein-based, especially animal-based proteins, and they're basically the things you most want to look out to when it comes to any types of taxidermy species, as well as upholstered furniture as well. They are distinctive as adults. As juveniles and larvae, they look very much the same. They kind of only really start to be trained once you're really, really trained at it. As adults, as you can see, the larder beetle has this very distinctive sort of tan yellow band that's also spotted around its middle. And the hide beetle has this sort of white and black marking on its pronotum, which is the connection between the thorax and the elytra and the wing case. And it also tends to have very kind of spiky, bristly body as well. And these tend to flourish indoors in the spring and summer, so that tends to be when they're at their most active. All right, so that is kind of the official Dirty Dozen in this region at least, but there are some dishonorable mentions, we'll say, so things that often kind of come up on and off the list, both depending on who you're talking to, the type of institution you're in, and where you are in the world. Cockroaches are one, just a sort of general gross yucky pest that no one really likes to see because they make themselves very conspicuous. But also they do like to eat cardboard and animal-based glues and adhesives, surprisingly, especially the German cockroaches. Also our wood borers, our powder post beetles, our death watch beetles, our carpenter bees and ants, and our termites. These are things, especially if you have historic sites, historic buildings. These are the things that can be really big structural baddies for basically the building itself. So these are things we definitely want to look out for, especially if you have historic sites and historic properties. And then other non-insects that are also considered museum pests, things like rodents and bats and birds, both because they will kind of destroy parts of your collection, collecting things either for their nesting material, for instance, and birds and mice. Also just kind of bringing in a general level of uncleanliness, and are also vectors for insects that can bring in insects themselves or attract them based on sort of their mess, their fecal matter, sort of what they're eating, their nesting habits, that can all attract insects as well. So these are also considered part of the pest list. All right, so what are we actually monitoring for? So some things to help you kind of identify whether or not there are insects present, whether or not they are actually in a collection, and sort of the magnitude of the issue is looking for their fracs, their excrement, their poop, which will show up in areas that they may be feeding. And every species has slightly different looking excrement, so you can get really up close and personal with it. There are actually databases that document insect fracs out there, so you can definitely go through those and see if you can identify species based on the composition of fracs. For wood boring issues, often the presence of both wood boring holes as well as copious amounts of sawdust around where those bore holes are could be indicators of activity. As well as the presence of things like eggs and casing, especially in the case of our closed moths. Also molts, some insects go through molting periods as they get larger and older. You'll actually find sort of little skin puppets left over from their molts. And then also damage to the collections themselves. So unfortunately, it's kind of the thing that most people tend to really get tipped off to knowing that there's a problem is when there is danger that is impacting the collections. So how do we identify and monitor pests? So how do we actually conduct our business over here? Well, as I mentioned a little earlier, we tend to use traps. You can use glue traps. You can also use pheromone traps, specifically, especially if you're looking for a very specific targeted species. If you're really kind of doing a survey that's very targeted to a particular species to see if that particular species is in your facility, then pheromone traps are very good. And what we do is we get a floor plan of we look at our space, we kind of map out our space. We look at where things like entrances and exits are, we look where storerooms are, we look at where there might be sensitive collections and where they are in the building. And then we make decisions about where we want to put those traps. Kind of bug symbols indicate a trap that actually belong in our maritime museum. So we place them, as you can see, in zones that are high areas of ingress and egress. So basically around doors and windows that are open to the outside, that may not be well sealed. There are areas that where insects and other types of pests that easily get into the building is where we tend to put our traps. We also put them in areas of food preparation or eating, like our kitchen, for instance. So areas where we know that there's going to be food around that could attract insects. That's where they go. Also areas that, we know that there are sensitive collections potentially in there that we might want to monitor just to see if anything's penetrating that far into the building, getting to those collections. And also areas where we know that there's been high traffic in terms of we've had sightings of insects before. We do have a way for our staff to communicate to us in collections if they're noticing insects in certain areas of the building, and we'll put traps there as well. Kind of see what's there and if it's how they're getting, and then kind of work backwards to see how they might be getting there. And once we identify our insects, we count them, and then over time, if you do this over a number of months and years, eventually you'll start to get an idea of sort of distribution patterns. You'll get an idea of what types of bugs exist where in your museum, and if that changes, if that's changed over time, if you suddenly have an increase, and if it's related to conditions like life cycle change or changes in weather. For example, we have an issue with shining chafer beetles who like to come to our building in the spring and summer, but they're very much seasonal visitors who just kind of incidentally get into our buildings. But they can reach pretty far, but I do keep monitoring those to see how far they're getting into the building and if they're getting near anything sensitive to them. All right, so you may ask, all right, I am happy to say that we have very little representation of the dirty dozen in our building. So we have the occasional varied carpet beetles and adult, but thankfully they are they're never really near anything of importance or anything that's sensitive, and I never find them consistently or in high enough numbers to sort of trigger that action threshold. So what are our type offenders? Well, I present to you the slightly soiled half dozen versus the dirty dozen. All right, number one, what could it be? Drum roll, please. It is a smoky brown cockroach, the state bird of North Carolina. Oops. So this is the smoky brown. It's these large, very dark black brown beetles. As juveniles, they're very distinctive because they have this black and white banding to them. So you can, even as very, very tiny little nymphs, you can still pretty much pick them up from the crowd pretty easily. And the most easy way to identify a smoky brown cockroach from others is by looking at this thorax head shield right here. It has a very distinctive, it is a solid dark brown, dark, almost black in sometimes color, whereas the American and German cockroaches, which are also frequent offenders, but not in as great numbers, have different patterns on their thorax head shield. So you can see that the American, for example, has this lighter banding of color around the base of the shield, and the German cockroach has these very distinctive stripe patterns. So that's a good way to sort of determine which cockroach is which, even though they all end up in the same place, which is getting chucked out the door, in the bin, or murdered. So that is our number one offender by far.
Is that the one that coastal resident?
Yes. They're all roaches. They're all different regional names for them, but they are all roaches. Number two are these little bugs, these little weirdos called springtails, Amida various species. They are these funky little bugs that have these very long segmented antennae. These guys really like damp and like humidity and like damp warm places. So it is not surprising that we find them around our drains and kitchens and around our baseboards, especially after a rain shower. They tend to try to congregate around water sources. Also, we have greenhouse millipedes. So you might see some of these coming into your house, into your bathroom after a heavy rainstorm. I know I have, but I live on the second floor. Somehow they get up there. So they have themselves, they actually eat other bugs. So they actually are a predatory species. So we kind of like them for that reason. However, there are a lot of them that turn up in the museum, especially after a heavy rain shower. And they're a good indication of sort of how far water might be seeping into your building or traveling through capillary action. So they are definitely, where we have water issues, we often find these little guys as well. So they are good indicators as potential water damage. Another insect, the ring-legged earworm. So kind of big, nasty looking guys with these pincers at the bottom of their tail, of their lower thorax region. These are also predatory bugs. They eat other bugs primarily, and they also are really attracted to areas of high humidity and water. So they're also good indicators that you have some water issues, there's been a heavy rainfall, things of that nature. All right, number 5. Various species of what we what we call drainflies. So drainflies actually represent several different species of various types of flies. The black-winged fungus gnat, the scuttlefly, and the mothfly are some of the most common offenders. The black-winged, they like to eat mold and fungus, as the name implies. So they are also drawn to areas of damp and warm. So there's a lot of water and moisture and are warm, kind of cozy places for that mold and fungus to tend to grow. So it could be an indicator of water issues as well as mold and fungus issues. They also like to breed and lay their eggs in your drains. So sometimes, if you've had a drain that's been closed for a while, you open it up and you're kind of accosted by a wave of little tiny gnats and other flies. That might be one of these guys. How we tell them? I mean, the mothfly is kind of a cute, fuzzy little bugger. They're usually pretty distinctive. But I will say the black-winged fungus gnat and the scuttlefly are kind of hard to just eyeball with the naked eye. I usually have to use a microscope to identify them. And what I'm looking at is the veining patterns in their wing structure, primarily to try to tell them apart. As you can see, the black-winged fungus gnat has this sort of wishbone or U-shaped formation in its veining, whereas the scuttlefly does not. And then the mothfly looks completely different. It's very fuzzy. Kind of cute little bugger, actually. Number 6 is kind of interesting, and that would be the rat wolf spider. We have a lot of these little guys. Also, they are a non-web based, so they are a traveling spider. They are hunting spiders, so they like to go out and hunt for their prey. So they are attracted to other bugs primarily. I also find a lot of young males, so I think they're also looking for love on the hunt, looking for a lady friend. Is what I mostly find. They do look very similar to the grass spider that we also have in here in North Carolina, especially just looking at coloration and body shape. So you might ask, like, okay, how do you tell spiders apart? A really good way to tell spiders apart is looking at the number and orientation and sort of configuration of their eyes. As you can see, the wolf spider has this very classic, very distinctive eye pattern where it has these 2 very large eyes, 2 more on the top of its head that actually kind of look like eyebrows, kind of has a perpetually surprised look to it. Where the grass spider has this kind of 2 rows of smile kind of shaped eye configurations to it. All right, and I'm going to throw in a bonus for a dirty half dozen. And so basically the bonus is, Michelle, what is your favorite insect of all or favorite arachnid of all to find in the museum? My favorite is this guy, the spitting spider. These guys are really freaking cool and really weird looking. Whenever I get one under the microscope, I'm very amused. They have very large cephalothorax, so basically head body pieces, and very tiny eyes. They look very jerky under the microscope, especially when they have these big mouth pieces that make them look like they have bug teeth. Sometimes they're known as the ogre face spiders because in up close and person, they do have that kind of ogre-y look to them. But under the microscope, because their eyes are so tiny, they look very silly. They also really cool because one of the reasons they have this really big bulbous looking cephalothorax is because they have a special gland on the top of their little heads that produces venom and silk. So they actually impregnate their silk with venom, and then they spit out that venom impregnated silk to capture their prey. And they do kind of a weird little serpentine dance to do it. They're really fun. I love them. They make me very happy whenever I find them. Do they make webs, or are they? They don't. No, they're not web-making spiders. Most of the spiders that I find in my traps are not web-based. Good question. All right, but the other important question, what is the cutest insect or arachnid that we find? Drum roll please. The cutest is by far the bull jumping spider. I love these little guys. They're adorable. How could you not love this little face? I am very happy to report I've only ever captured one in my traps, so I am not killing them, which I'm very happy about because they are very cute. But another non-web-based spider, they are good pest control for other insects that we don't really want in the building. So I tend to be very pro-spider in our building just because I know they tend to be hunting and eating and doing some of our pest control for us. But anyway, that is our capsule soiled half dozen plus of North Carolina. Anybody kind of notice that? Why are most of these bugs in your trap if they're not there trying to actually eat your collection? Well, as I may have mentioned or intimated, a lot of these are predatory insects. They're actually hunting for other insects. but will not also pass up a free meal. So it's kind of a little gray target situation where you have dead bugs that get caught in our traps, and then other bugs are attracted to the dead bugs thinking they're going to get an easy meal, only to end up covered in glue themselves and eventually, unfortunately, passing away. So in terms of prevention methods, so now that we know what's in our museum, what could potentially be eating our collection, what are things we can do to prevent them from either getting into the building or slow that down, or things we can do to prevent them from getting at the collections that are most sensitive potentially to them? Well, we can create barriers. So there's chemical barriers. So this is kind of, your insect control that you might hire to come in and spray down and put some sort of chemical around the entrances and exits and baseboards of your home or your domicile or your building. And this, basically creates a barrier that effectively poisons the insects or, might neurologically disrupt them or disrupt something in their digestive system that basically affects them and makes them die, essentially. We can also do things with diatomaceous earth or other types of desiccants, which can create a barrier that essentially dehydrates the insects, where they go through it, get covered in this desiccant or ingest it, and then essentially die of dehydration. You can also use things like naphtha or even kind of natural remedies like thyme and essential oils, which produce chemicals and smells that a lot of insects don't like. So they will avoid them based on the chemicals and the smells that are present in the materials. We also have physical barriers. For instance, you can keep your collections and very nice tight sealed stacks. For instance, like in this library setting, to try to prevent insects from physically being able to reach them. You can also put things in individual boxes or bags to try to create a physical barrier that will prevent or slow down an insect's ability to reach them. When I worked in the Natural History collection, one of my big projects was rehousing the entomology collection to make, because it was being eaten by bugs. So one of the very kind of easy fixes we did was to rehouse both our entomological collections as well as our fungi collections and other sort of mycology collections into sometimes even something as simple as a little plastic baggie that would just create that much of a little barrier to prevent an insect from being able to get to them. Also, that's also the premise around plastic sheeting or sort of covers around your material. And there's also behavioral barriers to actions that we take or policies that we enforce in our facilities to try to prevent insects from accidentally being brought into the museum or prevent them from being attracted to the museum. It's one of the reasons we don't allow foods except in certain designated food preparation and eating areas. Well, you can't just walk around eating, drinking Starbucks or eating your lunch, walking through the galleries to prevent food from ending up in the gallery and in the collection space. One of the reasons we don't allow pets, with the exception of service animals, into the building, just because they can unintentionally be the carriers of insects that can then get into the building. Same thing for potted plants and sort of live plants. There could be things in the soil, bugs in the soil, bugs in the plants that we don't know about when we bring them in that could then end up in the building and in our collection. So that's why we have that policy. And then we also do things like have separate foyers, entrances. You might have mats down to have people to wipe their feet on, places for people to put their coats and hats to prevent tracking in of dirt and other material from outside that could contain insects or contain things that might be tasty to insects. Other prevention, there's also habits in terms of policies that we as museum professionals enact, like good housekeeping, making sure that our museums are clean and that there's little to attract insects and sustain them, things like food waste or even just skin cells from guests, try to keep everything sort of nice and tidy and clean and try to reduce the food access they have. There's also good facilities maintenance, so making sure that your facilities are well sealed, that you have doors and windows which are well sealed, gasketed, that you don't leave doors and windows open even during high traffic times so that things aren't getting in, that you are maintaining good plumbing, that you don't have active leaks in your plumbing, for instance, that is contributing to damp problems that might either be attracting insects based on water as a resource or creating mold and fungus and attracting insects as a food source. And then also environmental control. So we also control the humidity and the temperature in our buildings to try to make sure that we're not creating like that nice, really warm, really high humidity environment that a lot of bugs really enjoy. In terms of actual control mitigation, when we do have a problem, if we notice that there is a problem with an artifact, or we even suspect that there could be a problem with an artifact that is being brought into the museum, we quarantine them. So that basically means that we keep them in their own secluded, sequestered area of the museum or loading dock, often sometimes bagged or in a container of some kind. So they're put in a container within a containment zone. And we kind of allow them to sit out there for a couple of weeks to monitor them, to see if we see any type of insect activity before we bring it into the collection. Also, one of the reasons we have loading docks and things, so that a lot of supplies that are being brought into the museum from outside have an area to kind of sit and chill for a period of time, both so they can acclimatize the building, but also just to make sure that there's nothing in them that could then get into the museum. So both as a preventative measure and then also kind of the first step you take if you do notice a problem. If you do notice a problem with an artifact, we immediately quarantine it, take it out of the collection, out of display, and put it by itself, and usually kind of bag and box it for further monitoring that, or to wait until we can actually deal with it. Step one for most things is that we thoroughly clean our artifacts and our facilities, not just the facilities, but the artifacts themselves, especially things that are upholstered, especially things that are textile based, vacuuming them, washing them sometimes, basically making sure that there's nothing in them so that if there are eggs, if there are larvae, we can sort of suck them up and remove them, also to keep them free of dirt and other things that might attract insects. There's also various types of kind of more active mitigation treatments. Inoxia and fumigation are two methods. Sulfuryl chloride is a classic fumigation gas where basically you take your object, you put it into some sort of container or barrier space, and basically keep create a pocket of something, a little chamber essentially where you can fill it either with a poisonous gas that can kill your insects, or you suck out all the oxygen from that container by using oxygen scavengers or replacing the oxygen with something like nitrogen gas, argon gas, or CO2. Basically what this does is that insects need air to breathe and metabolize just like we do. So denying them oxygen essentially will kill them. So this is the standard one where in oxygen treatments in particular, since we're trying to be a little bit creative, trying to get away from chemical-based treatments, we try to find other methods of killing the bug infestation. Inoxia, if used properly, will definitely kill the adults, definitely over time kill the larvae, and hopefully, and juveniles. And the idea is to do this long enough that any new eggs that, any new larvae that emerge from eggs will also be affected. And if for whatever reason, inoxia or fumigation is not appropriate to their facilities, or you can't get the materials to do it, or it's just not practical, or if you have a very large object or a very kind of fragile object, another way of sort of killing insect infestations in an object without using chemicals is to use temperature treatment. It means either putting them into very, very cold environments or very, very hot ones, which will essentially cause them to die. So basically temperatures generally under 29, negative 29 degrees Celsius, which is under 28 degrees Fahrenheit, or temperatures over 48 degrees Celsius, which is equivalent to around 118 degrees Fahrenheit, will often kill most active insect infestations at all life stages. You may need to do multiple applications of these types of treatments just to make sure you get everything, or sometimes do them for long periods of time, especially if you don't have a freezer, for example, that can get this low. If you have just sort of a standard household freezer, which gets to about negative 18 degrees Fahrenheit, there are calculators that you can find online that can tell you then how long the object needs to stay in that freezer for them to be pretty sure that you've probably frozen anything that's in there and killed anything off. Temperatures can be a little harder and trickier. We have a lot of very low budget ways of doing it, which could just be, we put this in the back of someone's truck on a hot day and leave it out there for several hours, and is enough to kill things off. So not every treatment method has to be super high cost or very, very complicated. Sometimes the simplest methods are still effective. And then, of course, there are traps. That kind of goes back, especially things like pheromone traps. If you are really targeting a particular species, there are traps that can be very, very effective to catch those, especially and that concludes the end of my presentation. Thank you very much for your time, and I appreciate it. If anyone has any questions, please feel free to ask. I will be here. Otherwise, please look forward to our next presentation occurring next week on February 27th, that Thursday. And we'll be giving a presentation on the maritime dimensions of coastal plantations. Otherwise, thank you very much. See you later, cowboy. I don't have any questions. Yes, sir. These insects, unfortunately, these are mostly pretty commonly noted pest insects for the most part. So, I mean, if it was a pollinator, that might be different, but thankfully I'm not getting a lot of pollinators in my traps. You know, occasionally parasitic wasps, which are not pollinators, but so that would probably be the one instance where that might be an issue. I would think some protected pollinator species, but for the most part, most of the species we're finding are very common household pests that you probably have in your own house for the most part. So I know I do. No, thankfully not. We don't have usually large groups of ladybugs congregating inside the museum. Occasionally we'll get one that flies in, often on a person, in which case we're just like, good luck, and then try to free it out of the outside if we can. I'm also one of those people who definitely put spiders and things outside when I can. I try not to kill things if I can help it. The pest monitoring system, unfortunately, the ones that we have do result in their death. But the majority of species that I do find are things that I would not be concerned about being a violation of any type of regular policy. So
I had caught unsick bugs off of the sick bats.
Thankfully, I've never caught anything that's not an insect. I know some facilities sometimes get reptiles and lizards and things, and sometimes small mammals trapped in them. Thankfully, I've never had to deal with that. So, but there are methods used to get them out of the traps if you get them in time, fortunately. Oh, good question. Out of these species, not that I know of, I think their mouth parts are a little too small to really do anything detrimental to us to really kind of get through our skin.
Caterpillar picture you had, cautious about knowing what they.
I still wouldn't go picking them up. I was trying to the larvae, especially the woolly bears, and the ones that have those fiber and things like that. They probably will cause some skin irritation. Like I don't think they're necessarily poisonous contact, but it could definitely cause some skin irritation. So I wouldn't necessarily go pick them off. I think so. All right. Well, thank you, everyone. Thank you very much, everyone, for your time.